Hello everyone, welcome to our channel Code with Sunny, and in this video I am going to talk about the problem N-ary tree preorder traversal. Okay, index number is 589 and the problem is of one of the easy problems of LeetCode. Okay, so before proceeding further, I am going to just give a quite overview that what I am going to discuss in this video. Okay, so first I am going to discuss what is this N-ary tree, and then I am going to discuss the preorder traversal of any tree, and then I am going to talk about the best solution, that is the two approaches to solve this problem, that is stack based approach and also the recursive method. Okay, so let's first read out the problem. Given the root of an array tree and we have to return the pre-order traversal of its nodes values. Okay, and what is this N-ary tree and how it is given in the input format? It is basically the serialized form, that is you can see when the nodes at a particular level are first printed, and when the level got changed, that is you can see the nodes at the second level 3 to 4 are the nodes values, it is being separated by a null pointer. Okay, that is 3 to 4, then it is separated by again null value, and the nodes are then listed for the third level, that is 5 and 6. Okay, so it is basically given in the serialized form. Okay, and also we have been represented for every node we have this two datas, that is the value of that node and also the children values. You can see vector node star of children, that is the what are the children of this my current node. Also you can see it is actually an array tree, so there might be some chance that the number of nodes, that is the number of children nodes of a particular node, can exceed the value 2. Okay, you can see this node with value 1 has 3 children nodes. Okay, since this is not a binary tree where the number of nodes can go at most 2, that is number of children nodes I am talking about. Okay, you can this in this case number of children nodes is going to be greater than 2. There might be some case. Okay, so that is node 1 has 3 children nodes, that is nodes with values 3, 2 and 4. Okay, and similarly this is a much more complex, like node 1 has a 4 children nodes 2, 3, 4, 5, and similarly you can see there might be some chances. Okay, for more number of children nodes. Okay, so I'm not interested in that, I'm just interested in how I'm going to just find out the pre-order traversal of its nodes values. Okay, so let's to look over the constraints. Number of nodes in the tree is in the range 0 to 10 power 4, that is there might be some root node with null address, so I need to take care of that base case also, and the height of the N-ary tree is going to be less than equal to 1000. Okay, so we can just easily find out the solution using recursive or using the stack based approach. Let's talk about first how we are going to implement this in the entire scenario with the help of pre-order traversal. Okay, that is what is this pre-order traversal, let's first find it out. Okay, you can see here is the tree that I have taken over here, and what is the pre-order traversal of this tree. Okay, so let's first talk about this binary tree, that is if we have been given this binary tree like this one. Okay, so let me do this stuff. Let me name this node like 1, 2 and 3, and let's say it is 4 and 5. And if we have been asked that what is the pre-order traversal of this binary tree, so one thing that should be kept in mind, that pre-order traversal is nothing but root, and then we have to go to the left subtree, and then we have to go to the right subtree. Okay, that is R subtree. That is first we need to traverse to the root, then we need to traverse to the left subtree, and then we need to traverse to the right subtree. Okay, so let's talk about how we are going to traverse with the help of this root node. Okay, so when we are at this root node, first we need to, so this root node is visited, so now we need to check for the left subtree. Okay, so this is the left subtree. Now this left subtree is again a node, and now if this is again a node, though this root node is visited, so I need to traverse for this left subtree, that is node with parameter 2, and we need to go for its left subtree, that is go to 4. So again you can see 4 has no child nodes, now this is almost traversed. Okay, now we need to backtrack, that is we need to go to the node 2 again, and if we have gone to the node 2 again, 2 is visited, 2 left child is visited, and what about the thing that is going to be left, that is 2's right child. Okay, that is the right subtree of this 2. You can see I need to come to again this 5. Now you can see 5 has no left child, 5 has no right child. Now this 5 is visited. Okay, now again we have to go to back to 1, and if you have gone back to the 1, then you can see 1 has no okay, so one's left child is visited, that is one's left subtree is visited, and the only thing that is left is one's right subtree. Okay, So now the visiting node would be 3, okay, and 3 has no child nodes. So you can see when you are going to just traverse in a pre-order fashion for this binary tree, it will be like 1, 2, 4, and then 5, and then back again to 3. So this is basically the root left subtree and this right subtree. Okay. So this is basically the pre-order traversal of this binary tree. But I'm not interested in binary tree. What about in general N-ary tree? N-ary tree is basically it is going to be implemented in the same fashion, that is with the same logic and with the same approach. Okay. So let's find it out how I'm going to traverse this N-ary tree. Okay. Now that one thing that needs to be memorized is that first we need to go to the root node, then we need to go to the left one, that is the leftmost node. So okay, so let's find it out. What is the leftmost node? So one is the first root node, so I need to visit one. And what is the leftmost node of the, that is the leftmost children node? Okay, it is going to be 3. So now it is going to be 3. Okay. Now if 3 is considered again as a single node, what is the leftmost child node? You can see it is going to be 5. Okay. Now this is the same way that you need to traverse. Okay. Now you can see there are no nodes of this 5, no child nodes of this 5. Okay. So it is going to be traversed. Okay. So I need to backtrack, again come to 3. Okay. Now we need to go to the next child node. Okay. So in case of a binary tree, you need to go to left subtree, right subtree. Okay. But in case of an array tree, you need to go to leftmost children and then to the next leftmost children NLC, then go to the next of leftmost children, and so on. Okay, up to the rightmost child nodes of a particular node. Okay, now again you visit the node 6. Okay, now if you visit this node 6, you go to back to this node 2, because 2 is the next leftmost child node of this node 1. So this 2 should be visited. Now you can see 2 as a node, no children nodes, so 2 is done. And again we go to this 4. Okay, sorry. So we go to this 4, because 4 is the next leftmost node of this root node 1. Okay, now this is done. 1, 3, 5, 624 is the pre-order traversal of this N-ary tree. Let's check it out if I've done correct or wrong. 135,624. Yes, it is correct. Okay. So this is basically the recursive way. Okay. Now you can see you can easily implement this recursive fashion, the of pre-order traversal. Okay. Now you need to consider that root, then the leftmost, and then to the next leftmost, and until so on. Okay. So one thing that you should write in a recursive fashion is, if you need to have write the traverse function of this pre-order traversal, you first need to write the base condition, that is if root is going to be null, then return. Otherwise, I am at this root node. If I am at this root node, I need to take it into my answer vector. Why we should take it into an answer vector? It is just simple that we are first going to traverse this root node, then left, then next left. Okay, so if you have encountered this root node, I need to take it into my answers. Okay, so after this condition, you have to write, just push the answer dot push back this root's value. Okay. Okay, if this is done, I need to just traverse from leftmost to the rightmost child node. Okay. So I need to traverse from the leftmost to the rightmost child node. Okay. So I need to just iterate through all the child nodes and just call this function, let's say fn, again for every child node. Okay, why? Note that I need to traverse from the left to right. Okay, because you can see in a pre-order traversal fashion, I need to first go to the leftmost for a n-ary tree I'm talking about. Okay, leftmost, then to the next leftmost, and so on. Okay, so that in the same case, like 1, then 3, and then all the 3 nodes is going to be visited. That is, we need to talk about now for the single node of this tree and for all the child nodes of this 3, then again and again in a recursive fashion. If 3 is done, now we need to go for this 2 and again go for this 4. Okay, so when my recursive function call for this 3, now this is again a new function call calling for this node 3. Okay, and we are going to do this in a recursive fashion. Okay, just like a simple pre-order traversal of this binary tree, and in this case only difference is we need to consider for more than 2 child nodes. Okay, for a particular node, and the only difference that you should observe that we are going to just iterate from the leftmost child node to the rightmost child node and call this recursive function again and again. Okay, so this is basically done. So I need to talk about now stack based approach. Okay, so let's talk about how we are going to do this with the help of stack. Okay, so let's talk about the stack based approach or queue based approach. Which one should be correct and which one should be implemented? Okay, so the basic definition of stack and queue is nothing but a stack is uses first in, last out. Okay, yes, it is correct. Okay, so and what about queue? Queue is just uses first in, first out. Okay, now one thing that should be memorized is that first I need to visit 1, then I need to visit 3, then I need to visit 5. Okay, so this only 3 steps will make the clear entire concept of which one should I use, stack or queue. Okay, so you can see the stack is like first in, last out. Okay, so when we try to push the child nodes of this one, I have the stack stop as this node with value 3. Okay, so I need the stack stop should be node with value 3. Okay, so I need to push the nodes from the backside of this, you can see backside of this child nodes. Okay, so I need to push 1, then push, okay, so sorry, I need to push this 4, then I need to push 2, then I need to push 3. Okay, so this is the basic push operations of the stack. Okay, so after pushing the child nodes of this one, it should be like, you can see I have this of these stacks elements like 3, 2 and 4. Okay, so I am going to pop this stack top and I am going to again push the child nodes of this stack top, that is 3, in the reverse fashion, that is 6 then 5. Okay, so when I push 6 then 5 in a stack, then a stack stop would be like, you can easily understand, it should be like 5, 6 and then 2 and then 4. Okay, then I am going to pop this 5 out and I have this stack top as like 6, 2 and 4. Then I'm going to pop this 6 out because 5 has no child nodes and similarly 6 has no child nodes. Then it should be like 2 and 4, then again 2, then again 4. Okay, so you can see if we find out the what are the stack top that we have visited sequentially, it should be like 1, then it should be like 3, then 5, then 6 and then 2 and then 4, and it is going to be correct pre-order traversal of this N-ary tree. That is, we need to push the child nodes in a reverse fashion, that is in reverse, that is 4, 2, 3. Okay, so this stack based implementation of this N-ary pre-order traversal is going to be correct and it will give us a correct answer. Okay, so let's talk about why this queue implementation is going to fail. Okay, so let me first erase this stuff. Okay, now one thing that should be memorized, that queue uses first in, first out. Okay, so I need to push this 3 node first, so that after pushing all the child nodes, 3 should be at the front of this queue. Okay, so I should push the nodes in a starting fashion, that is from leftmost to the rightmost child node. Okay, so it should be like 3, then 2, then 4. Okay, so this is the element of the queue and 3 is going to be the front element, front. Okay, now let's talk about if I'm going to pop this 3 node out and push the child nodes of this node 3, that is I'm going to push 5 and push 6. Okay, so when I'm going to push this 5 and push this 6, you can see I have the nodes, I have this queue as 2 should be 4, 2, then 4, then 5 and then 6, and 2 would be the front node. Okay, so you can see the nodes visited sequentially from the queue's front would be like 1, then 3 and then 2. Okay, so you can see 2 is not the required element at this position for the pre-order traversal. It should be 5 and we are not getting 5. In spite of that, we are getting 2. So this is going to be wrong. So you can also understand that the correct pre-order traversal is 1, 3 and 5. That is, I need to visit 5 now. Okay, so this is going to be wrong. So queue implementation is going to be wrong. Okay, so I need to use a stack based implementation. Okay, so let's move further to the coding part, how we can implement this, you can say the recursive solution, stack based solution in the real world scenario, that is in the coding section C++. Okay, so let's move further. Okay, so let's talk about the implementation. Okay, so basically I've already submitted some codes, that is two accepted codes of this one. First one is I think recursive one. Let's talk about it directly. You can easily see I have this vector int answer defined as globally for every function call of this pre-order. I will just clear this answer vector. Okay, now I'm just going to call this traverse function, which is nothing but traversing in a pre-order fashion, that is root left subtree and right subtree. It is just basically for the demonstration purpose. I have just written left subtree and right subtree. In case of N-ary tree, first you need to visit from the leftmost child node, then you are going to visit for the rightmost child node. Okay, so it should be like first traverse function is called. If root is going to be null, just return as it is because I have no valid nodes address. Okay, So otherwise I'm going to just push back the roots value, and for every child node starting from the leftmost child node, I need to push the child nodes of this my current node. Okay, so just I'm going to push this child node and recurse, and this recursive function is going to be called repeatedly for every child node. Okay, so this is going to be a good solution for that. Let's talk about the, you can say, the stack based approach. It has also runtime beats of 79.98 of CPP submissions. And what about this one? It is also the same. Okay, now this is basically stack based implementation. You can easily see this answer is going to store the answers, and if root is going to be null, return answer as it is, because you can see if you have the base case, like if you look over the constraints, it is like nodes, number of nodes is going to start from the 0. Okay, so I need to take care about the base case, and I've made the stack of node start, because you can see I have this node class defined over here, so I need to consider for this node start. Okay, so first I have pushed the root node, and while stack is non-empty, I need to just pop out the stack top, and I need to just append to my answer vector the nodes current nodes value. Okay, now we need to push the stacks, we need to push the nodes, that is children nodes of this current node, in a reverse fashion, that is starting from the last children node and going to the leftmost children node, that is from the rightmost to the leftmost, so that after every popping operation of this stack, I have the, you can see the node in a pre-order fashion. Okay, so again this is going to process while stack is going to be non-empty, finally return the answers. Okay, so this is basically the stack based approach. So if you have any doubts, do let me know in the comment section of the video, and I will ask you to like this video, share this video, and do subscribe to our YouTube channel for latest updates. Thank you for watching this video.